Alcohols, primary to polyalcohols. Let me start by explaining what is meant by primary, secondary, and tertiary alcohols. Here we have one propanol. The hydroxyl group is attached to carbon number 1, which is itself attached to one other carbon. COH is attached to one carbon. We call this type of alcohol a primary alcohol, which is symbolized like this, 1 with a degree symbol. This is 2-propanol, and COH is attached to 2 carbons. So this is called a secondary alcohol, also symbolized like this. And finally, as you can see, COH is attached to 3 carbons, making this a tertiary alcohol, symbolized again like this. As for naming the last one, notice the longest chain is 3 carbons with methyl on carbon 2. This is 2-methyl-2-propanol, but there is another name. There are 4 carbons altogether, so the prefix is bute, but because it's a tertiary alcohol as well, we can combine them and call it tertiary butanol, or T-butanol for short. So this is what we mean by primary, secondary, and tertiary alcohols. Now let's look at what are called polyalcohols. These are alcohols containing 2 or more hydroxyl groups. The simplest one, containing 2 hydroxyl groups, is called a diol, di meaning 2. Diols are alcohols containing 2 hydroxyl groups on different carbon atoms. With 2 carbons in this example, the base name is ethane, so according to UPAC, or IUPAC, this is called 1,2-ethane diol. The name can be split to give ethane 1,2-diol. Here is a line diagram. The common name is ethylene glycol. I need to pause here briefly to explain these 2 words. Ethylene comes from the idea that the original starting material is the alkene called ethylene, and when the 2 hydroxyl groups are attached by a chemical reaction, the double bond is replaced by a single bond, and this diol is the result. Now, what is glycol? The compound glycerin was known since the middle 1800s, as was alcohol long before that. The combination of these 2 molecules resulted in a diol, but the name was taken from glycerin and alcohol like this to form glycol. So glycol is in fact the same as a diol, in which 2 hydroxyl groups are located on 2 different carbon atoms. Think of diol as the UPAC name and glycol as the common name. This one has 3 carbons with 2 hydroxyl groups on a propane skeleton. The name is 1,2-propane-diol, or propane 1,2-diol. Here is a line diagram. It too has a common name, propylene glycol. The final example is named 1,3-propane-diol, or propane 1,3-diol. A line diagram. How would you name these 2? The first one with 4 carbon atoms is 1,3-butane-diol, or butane 1,3-diol. For the next one, let's number it. Notice we start here because we have a hydroxyl group on carbon 1. We must number the carbon chain so that both hydroxyl groups are in the numbered chain. Again, it's a 1,3-butane-diol. On carbon 2, we have 2 ethyl groups, giving us 2,2-diethyl 1,3-butane-diol, as well as 2,2-diethyl butane 1,3-diol. Now, I want to spend a little time on properties and uses for the first 2 glycols because they are very pervasive and important in our society. Ethylene glycol is a sweet, syrupy, colorless liquid, but it is toxic. Its main use, by far, is as a component in antifreeze. Here's a typical container of antifreeze, and here is one which actually shows ethylene glycol on the front. Minor amounts are also found in shoe polish, some inks dyes, and latex paint. Here's an ink cartridge. The ethylene glycol here keeps the color dyes in solution and also slows down evaporation, which prevents the nozzles from clogging. And here's an example of latex paint. Now, let's look at propylene glycol. It is a colorless liquid, sweet, but this one is non-toxic. It's used in the food industry, for example, in ice cream and baked goods. Here's ice cream and donuts. The propylene glycol is good at maintaining moisture and flavor. Because it's non-toxic, it's also found in packaged foods, soft drinks, food coloring, bread, cake mixes. You get the idea. Here is a cake mix showing all the ingredients, and so many of them. Here is propylene glycol. It is a component also in the de-icing of aircraft, in vaping. It carries the nicotine and flavors, in fog or smoke machines. One final polyalcohol I want to acquaint you with is Glycerol. This is its common name. It consists of a propane base and 3 hydroxyl groups. Here's another way of showing it. The hydrogens are on the left for clarity. The name is 1,2,3-propane triol. Here is a line diagram. Glycerol is sold in stores with the label glycerin and not glycerol. Why is that? Before the structure of glycerol was known, it was thought that nitrogen was present in this molecule. Such molecules usually ended in or -ine, like amine or vitamin. By the time it was discovered that there was no nitrogen and only alcohol groups, the name glycerin was well enough entrenched in the language that it remains so today. Now, 2 more names to show just for completeness. They are not essential for you to remember, but you may come across them sometime. If the 2 hydroxyl groups are on adjacent atoms like this, side by side, the diol can be referred to as a vicinal diol. And secondly, a geminal diol is one in which the 2 hydroxyl groups are on the same carbon atom as in this example. Think of Gemini, the twins. Now back to glycerol. Glycerol is a thick, sweet liquid, also non-toxic. It's used in cosmetics and in chocolates. Again, this is only possible because of its non-toxic nature. It's used to keep cosmetics and chocolates moist, and it keeps the moisture evenly distributed. It's also used to make nitroglycerin, which I will focus on now as the last molecule. Nitroglycerin is formed by replacing the hydrogen in each case with a nitro group by reacting glycerol with nitric acid. Now, this group, which includes oxygen, is called nitroxy. There are 3 nitroxy groups here, giving us the name 1,2,3-trinitroxypropane. Its common name, as shown, is nitroglycerin. It is used to counteract angina or chest pain when not enough blood gets to the heart. Nitroglycerin opens up the arteries to allow more blood flow. It comes in tablets like this, or as a spray or patch or injection. These nitroxy groups are highly unstable, and in the liquid state, it is a very explosive material. Now, it may seem ironic that a highly explosive material can be taken for heart problems, but as the label shows, only a very small amount, 0.4 milligrams, is present in a tablet. In the middle 1800s, a Swedish chemist and engineer named Alfred Nobel discovered how nitroglycerin could be made safer to handle and transport by absorbing it into diatomaceous earth. This close-up shows it is made from the remains of tiny marine organisms that died long ago, and is mostly silica, the same component found in sand. It was packed into sticks like this, which you may recognize as dynamite. In this way, nitroglycerin remains safe until it is detonated. Nobel made his fortune from dynamite, and his money funds all the highly valued Nobel Prizes. This ends the... Uh-oh.